if you look at the first sheet, now, right at the front end, we talked about the area of a parallelogram. What's the area of a parallelogram? Base times height. Do not mess that up, okay? The height of that parallelogram is not that line, okay? You would have to find the height of it, or if they give you the height of it, a lot of times what they'll do is they will give you like an angle, okay? Now, right underneath that on the study guide, I did your special case triangles. You guys just basically blew off the special case triangles, so we'll use trig here. Okay, let's say that this is 18 at the bottom, and let's say this is 10. And I want to know the area of this parallelogram. Well, I know the base. The base is going to be 18. What I don't know is the height, but what I have is the hypotenuse. What I need is going to be the opposite, which is sine. So I'm going to go the sine of 30 degrees is equal to A over 10. So I'm going to take my calculator. And I'm going to go A times the sine of, or 10 times the sine of 30. And it's going to give me 5. Okay, so I'm going to find out that that's equal to 5, which is the height here. So then I'm just going to put that in there. It's going to give me 45 as my area of that parallelogram. Okay, you're good on that. Okay. And that's that whole first page. I mean, I did it out. Then page 2 talks about the area of a triangle, trapezoid, and rhombus. And I have the formulas there, but please do not misunderstand me. Those formulas will not be listed on the test. You've got to know those formulas. So, without looking at it, what's the area of a triangle?
1/2 base times height.
1/2 the base times the height. So very similar to this, except for you're putting a, well, and I don't even know why, shouldn't have done the 1/2 there. Okay, it should have been 18 times 5. Okay, so if that had been a triangle, it would have been 1/2 18 times 5. Okay, what about a rhombus?
The diagonals times each other times 1/2.
Good. 1/2 diagonal 1 times diagonal 2. So you just find the diagonals. Obviously, they might put you on a coordinate plane and have to use the distance formula. Okay, what about a trapezoid?
1/2 the height times the two bases.
Okay, 1/2 the height times the two bases added together. Make sure you add it together. Now, if I had a trapezoid, be careful on this because I think it messed somebody up on something. I can't remember what it was. Okay. So let's say you've got 1/2, and this is 10, and this is 12, and 14. If you do not put parentheses around that, the calculator will not do it right. Okay, because it's going to go, if you go 0.5 times 10 times 12 plus 14, you know what it's going to do? It's going to do that whole thing first, and then it's going to add 14 to your answer. So make sure you put parentheses around those last two numbers that you're adding together. Okay? Again, you're going to, might have something that's made up of several of those shapes. You got to be able to cut it up and add those shapes together. You have to be able to put it on a coordinate plane and be able to go, oh, the distance horizontally is the difference in the x's, the distance vertically is the difference in your y's. Okay? So that was section 11.2. Section 11.3 had to do with the circles and the regular polygons. What is the area of a circle?
Radius squared times pi.
Okay, pi r squared. Find the radius, which is always going to be half the diameter, square it, multiply it times pi. How do you find the area of a regular polygon?
The perimeter times the apothem
Times 1/2.
times 1/2.
1/2 the perimeter times the apothem. The only ones that don't have the 1/2 in it are going to be your parallelogram, your rectangle, and your circle. Everything else has that 1/2. Okay. That is where you could get tripped up, but understand that that's where you're gonna bring trig into it, and you're gonna know that if it's a regular one, so let's say it's a hexagon. Okay, five-sided figure, which means there's 5 triangles in it. Okay, which don't at all look consistent. Okay, so the apothem, remember, is the line perpendicular to a side. Okay, on this particular one, we've got 5 triangles, so we take the 360 and divide it by 5, which is going to give me 72. So this whole thing is 72, but I'm only interested in half of it because I want the right triangle. So that's going to be 36. Now, I don't know what they're going to give you. They might give you a side, they might give you the apothem, they might give you down here. But depending on what they give you, you're going to have to work backwards. Let's say they tell you that this is 10, okay? If they tell you that's 10, so the area is equal to 1/2 the perimeter times the apothem. What's the perimeter if that's 10?
50.
50, okay, because each side is going to be 10. So that's going to be 50. Then I can find the apothem, knowing that both of those are 5. So I am interested in the tangent here, because that's opposite and adjacent. So the tangent of 36 is equal to opposite over adjacent, which is the apothem. So it's going to end up being 5 divided by the tangent of 36. Y'all understand why that's the case? Okay. Kind of shortcut now here. Okay, so I'm going to get a 6.9 right there as your apothem. So I would just put that in my calculator and I would be done. Okay. That is 11.3. Now you guys know that they made life a little bit more complicated than that, but these are the basics. This is the basics that we're going over. Okay, then the area of the irregular figures was when they started putting things together. And you go, oh, that's a half a circle. So I'm going to find the area of the circle and I'm going to divide it by 2. That section you need to think your way through. Okay, don't just do it by autopilot, because you'll forget to take half the circle for the half of circle, or you'll forget to take the triangle out or whatever. So that's putting it together, and then that brings you to the geometric probability, okay, which is what you just did. That's that whole chapter. Okay, I think you got it, okay, but you could make careless mistakes on it. So what I'm going to do is I am going to give you your homework. Obviously, we can call it homework, we can call it classwork, we can call it whatever. I want it done now, okay? We might get to go over it, okay, so that you would start in with a test first thing tomorrow, okay, when you come in. We'll just see, okay? Depends on how long it takes you. Okay, page 628 through 630. I want you to do now, this is not a mistake, because the first part has to do with formulas, okay? So you are going to start at 1 here, and you're going to go 1 through 20 all, okay?